Good morning, everyone. My name is Naili Sabir, and I am here to teach you about geometric optics. A ray of light is an extremely narrow beam of light. All visible objects emit or reflect light rays in all directions. Our eyes detect light rays. We think we see objects, we really see images. Images are formed when light rays converge. When light rays go straight into our eyes, we see an image in the same spot as the object. It is possible to see images when converging light rays reflects off of mirrors. Reflection is when light changes direction by bouncing off a surface. When light is reflected off a mirror, it hits the mirror at the same angle as it reflects off the mirror. The normal is an imaginary line which lies at the right angles to the mirror where the ray hits it. Mirrors reflect light rays. How do we see images in mirrors? We perceive all light rays as if they come straight from an object. The imaginary light rays that we think we see are called sightlines. Real images are formed by light rays. Virtual images are formed by sightlines. In a plain flat mirror, images are virtual, formed by sightlines, and upright. Objects are not magnified. Object height equals image height. Object distance equals image distance. Concave mirrors. The first ray comes in parallel to the optical axis and reflects through the focal point. The second ray comes through the focal point and reflects parallel to the optical axis. A real image forms where the light rays converge. Example number 2. The first ray comes in parallel to the optical axis and reflects through the focal point. The second ray comes through the focal point and reflects parallel to the optical axis. The image forms where the rays converge, but they don't seem to converge. A virtual image forms where their sight rays converge.
Now, convex mirrors are the kind of mirrors that are curved outwards. Now, the line that you can see that passes between the convex mirror is called the optical axis. And in the middle part, where the convex mirror is located, can be seen the focal point. Now, light rays that come in parallel to the optical axis reflect from their focal point. So you can see as the light rays pass and bounce from the convex mirror, they are in parallel with the optical axis, and they all reflect there from the focal point. Light rays that come in parallel to the optical axis reflect from the focal point. The focal point is considered virtual since sight lines there, the broken lines that you can see there, they're called sight lines, not light rays, because they go through it. There. Now here is an example. The first ray that comes in parallel to the optical axis, and it reflects from the focal point. The second ray of light that comes through the focal point, and it reflects parallel to the optical axis. The light rays don't converge. They don't converge as can be seen here, but the sight lines do. The sight lines are the lines that can be seen within there, the focal point and the convex mirror. Here, the sight lines is this line and this line. The lines that are created from the mirror, they converge at here. A virtual image forms where the sight lines converge. So from here, where they converge, an image, a virtual image is formed. Now here is another example. Let's say the object is here. The first light ray passes through here and bounces back. And the second ray of light bounces here and goes through there, which is all parallel to the optical axis. And the lines that converge here are called the sight lines, and there, here, is where the image is formed. So lens and mirror equation. The F stands for the focal length, the DO stands for the object distance, and the DI stands for the image distance. F is negative for diverging mirrors and lenses. DI is negative when the image is behind the lens or the mirror. Now here is the magnification equation. M stands for magnification, HI stands for image height, HO stands for object height. Well, if the height is negative, the image is upside down. And if the magnification is negative, the image is inverted, which is upside down. Now, here is refraction. Refraction is when the light bends as it passes from one kind of medium to another. When light traveling through air passes into the glass block, it is refracted towards the normal. So here is the normal, and as it passes through another kind of medium, which is the glass block, it is refracted. It bends. The light passes back out of the glass into the air. It is refracted away from the normal. So let me repeat it again. When light travels through air and passes into the glass block, it is refracted towards the normal. And when the light passes through the glass block and goes out again into the air, it is refracted away. So when it goes into the glass block, it is towards, and when it goes back out, it is refracted away from the normal. Since light refracts when it changes mediums, it can be aimed. Lenses are shaped, so light is aimed at a focal point. Lenses. The first telescope designed and built by Galileo used lenses to focus light from far away objects into Galileo's eye. His telescope consisted of a concave lens and a convex lens. So here's the eye, and it is a mixture of both. This is the concave lens, and this is the convex lens. So the light from the far away object is here. Light rays are always refracted, which is another term is bent, towards the thickest part of the lens. And that concludes our report.